So we have potential. This potential is equal to 0 if x is between 0 to a and infinity otherwise. So this is my system, and obviously this system is identified as what? Particle in infinite box, isn't it? Okay. Between of infinite box of width a, and it is centered at a by 2. So I think this system is this one, isn't it? Okay. So what will be energy eigenvalue and eigenfunction of this particular system? So energy eigenvalue and eigenfunction is, we know original Hamiltonian or unperturbed Hamiltonian, h phi n is equal to n square E naught phi n, where n can be 1, 2, 3 and so on, and E naught is parameterized as pi square h cut square upon 2m a square. And what is your phi n? Phi n is equal to root 2 by a sine n pi x upon a. So this is our phi n, and obviously this is between 0 to a and 0 otherwise. Okay, so this is my unperturbed Hamiltonian. So we have to go step by step for different type of perturbation. So first perturbation is hp is equal to lambda v naught when x is between 0 to a by 2 and is equal to lambda v naught by 2 when x is between a by 2 to a. Okay, so obviously which type of perturbation is there? This perturbation is something like this, isn't it? Step kind of thing or shaft kind of thing, है ना? कुछ ऐसा perturbation है. This is my first problem, obviously between 0 to a. The second perturbation is hp is equal to v naught x upon a, where x is between 0 to a and 0 otherwise. This is our second perturbation. Which type of perturbation is there? कैसा perturbation है ये?
Sir, increasing होगा sir.
Obviously base is slightly
Linearly increased.
ऐसा है ना? So this is disturbance, this is disturbance, this is something disturbed thing, and obviously lambda is, and you can also put lambda, don't worry. So lambda is some parameter which will be less than 1. Let's go for third one. hp is equal to lambda v naught a delta x minus a by 2. Fourth one, hp is equal to lambda v naught a delta x minus a by 4. Okay, and fifth one, hp is equal to v naught cos pi x upon a, and lambda you can put where x is between 0 to a. Okay, so these are 5 problem we are just try to solve. Okay, so ये वाला कैसा हो गया? सबको फिगर से दिखा रहे हैं तो इसे भी दिखाई देते हैं. What will be third one? Dirac delta at a by 2. Okay, what will be fourth one? Dirac delta at a by 4. So a by 4 is something like this. Okay, fifth one कैसा होगा ये? This is something like cos function, है ना? This type. ऐसा ही है क्या? No.
Yes sir.
नहीं नहीं ऐसा नहीं होगा. This is 0 पर क्या होगा cos की वैल्यू? Maximum. Okay. So this will be something like this, है ना? Yes, a by 2 per minimum, and again it will be negative. Yes,
Yes, yes.
this is something like that. Okay, so these are 5 perturbation, and let's see. And what we have to do, we have to calculate in each and every time. We have to calculate EN1. हमें क्या कैलकुलेट करना है? EN1. Okay, EN1 is what? First order energy correction. Okay, first order energy correction in nth state. Ground state, first state, excited state नहीं, nth state की बात कर रहे हैं, any nth state. Okay, so let's try to go for step by step. मैं इसे मिटाता हूं, होप आपको याद रहेगा, है ना?
Yes, sir.
Okay,
Yes, sir.
चलो, so let's try to go for this. So first one, EN1 is nothing phi n W phi n, and obviously we have to go for the integration, है ना? And what is integration here? First integration is 0 to a by 2. What is W here?
V naught.
Phi n star V naught phi n dx plus a by 2 to a. What is this value? Phi n star V naught by 2 phi n dx. We can take phi n outside, sorry, V naught outside, and we have 0 to a by 2 mod phi n square dx plus V naught by 2 mod phi n square a by 2 to a. Now, क्या इंटीग्रेशन करना जरूरी है?
No, sir.
No, because we know this particular value of integration. क्या होगा इसकी वैल्यू?
A by 4, sir. A by 4.
हाँ?
A by 4. A by 4, sir.
मतलब कुछ भी बोल दोगे? This is nothing but the probability between 0 to a by 2 and the nth state. So that is 1 by 2.
Sorry, sir. 1 by 2.
Please be sensible.
1 by 2 हो जाएगी.
हाँ? So
A
that
by 2
value is equal. देखो दीपक, ऐसे बात नहीं करो, ठीक है? एक तो गलत करते हो, फिर सॉरी सर करते रहते हो. So what is this value? 1 by 2 plus what is this value? Again, second one is what is this integration? कर चुके हैं हम लोग. A by 2 से A तक भी क्या होगा? Probability is between, that is again 1 by 2. So yes, we have used all the concept of particle in box. Yes. So this value is V naught by 2 plus V naught by 4. That means this is 3 V naught by 4. Very simple, very easy, but ये भी आपके एग्जाम में आ चुका है. Okay, let us go for second one. What is your second one? EN1 is again we have go for phi n x phi n, and what is your x here? Sorry, phi n w. What is your w here?
V naught x by a.
So V naught by a को बाहर ले रहा है, and we have phi n star x phi n dx 0 to a. Can we say what is this particular integration?
A by 2.
A by 2. This is nothing but the expectation value of x on a nth state, and that is a by 2. Yes?
Yes, sir.
Clear here?
Yes, sir.
So this is something V naught into by a into a by 2, and that value is equal to what? V naught by 2. Clear है ये? Second question भी हो गया. So this is my first one. This is my second one. Let's go for third one. Third one में क्या दिया हुआ है? Dirac delta.
Yes, sir. A by 2
Okay.
का Dirac delta.
क्या दिया हुआ है? V naught So third one is, again we will go for phi n star, और यह क्या है, V naught into A delta x minus A by 2 into phi n, and obviously we have to go for dx. So obviously we can take V naught A outside. Now we have to go for integration. So what is this value? 2 by A will come here, and you have sine square n pi x upon A and Dirac delta x minus A by 2 dx between 0 to A. Obviously this is delta function at x is equal to A by 2. So what is this integration?
1 square n pi by 2.
So this value is V naught, A and A will be cancelled, 2 V naught into sine square n pi by 2, isn't it? And this value is equal to 0 for n is equal to odd even number, isn't it? And this value is equal to 2V naught when n is equal to 135. Please be conscious. बेवकूफों की तरह तुरंत मत कुछ बोला करो, है ना? So there are two possibility. Either it will be 0 or it will be 2V naught. ये last year या last के last year exam में आया था. Okay? Clear है ये? Okay. Let's go for fourth one. Let's go for fourth one. So fourth one is, we have basically क्या था हमारा, delta x minus a by 4 है ना? So again we will go for 0 to a phi n star v naught a delta x minus a by 4 phi n dx. So again you have to be very much careful. So v naught into a into 2 by a, and we have integration sine square n pi x upon a and delta x minus a by 4 dx. Again we will go for 0 to a. So what is this value? So you have v naught into a is cancel out. So 2v naught into sine square n pi by 4. So now we will put value of n. So क्या होगा इसकी value? If n is equal to 2v naught into n is equal to multiple of 4, then what is this value? 0. Yes?
Yes, sir.
This value is equal to 0 when n is equal to 4, 8, 12, and so on. Good. And this value is equal to 2v naught into 1 by 2 for n is equal to 1, 3, 5, and so on. है ना? Sine square pi by 4, 1 by root 2 का whole square, this one. So this
Yes,
value
sir.
is equal to what? V naught when n is equal to 1, 3, 5, and so on. अब क्या क्या बच रहा है? Now 2,
2
6, isn't it? This number is still there. So that value is equal to 2v naught when n is equal to 2, 6, 8 is not there, then 10, 12 is not there, then 14,
14.
and so on. And so you have three different value. Either it will be 0, it will be v naught, it will be 2v naught, depends on what is their higher value. What is, I am just writing here. So this value is equal to 2v naught, and this value is equal to n is equal to, for n is equal to 1, 3, 5, sorry, क्या ये? That is 2, 6, 10, and so on. That is not divisible by even, but not divisible by n. So that value is equal to sine square n pi by 2, and this value is equal to what? 1. So are you people comfortable?
Yes.
Okay. So let's go for next problem. देख रहे हो कहीं भी कोई खास इंटीग्रेशन करने की जरूरत नहीं पड़ रही है ना?
Yes, sir.
बिकॉज हमने पहले ही बहुत ज्यादा मेहनत कर लिया है, सारा चीज पहले से ही कर रखा हुआ है. यस, ओके. सो लेट्स गो फॉर नेक्स्ट वन. लास्ट वाला क्या था? Vx इज व्हाट इज HP? HP क्या था?
V naught cos pi x.
V naught cos
Pi x upon
pi x upon A. ओके. सो V naught by, चलो ठीक है, रहने देते हैं, जो भी आएगा देख लिया जाएगा. व्हाट विल बी दिस वैल्यू? सो En1, that value is equal to, again we will go for pi n star V naught cos pi x upon A, and you have phi n dx. What do you have? क्या क्या बाहर आ जाएगा? 2 by A V naught. Inside we have sine square pi x upon A, and we have cos pi x upon A dx 0 to A. What will be this value? क्या होगा इंटीग्रेशन का? This will be something like sine cube by 3, isn't it?
Yes.
है ना? ऐसे कर सकते हैं. Just check it. Sine pi x by A is equal to t. Then what will happen? Cos pi x by A, and obviously dx is equal to A upon pi dt. Yes.
Yes.
And when x is equal to 0, then this value is 0, isn't it? And x is equal to A, again this value is 0. My goodness, what is happening here? So we will put this limit thing after one. After that, so this will be t square dt, isn't it? And you have A upon pi, and then what will happen? A upon pi, and this value is equal to what? T cube by 3. यही होगा ना? And now this value you can put A upon pi, and t cube by 3 is basically what? Sine cube pi x by A by 3. Now I can put 0 to A, because it will be very uncomfortable that 0 to 0, isn't it? है ना? So now you can put it, that value is 0, isn't it? So obviously there is not any perturbation for first excited state. Sorry, for first order energy, है ना? First order correction. क्या हुआ?
लिमिट सेम आ रहा है, वहां ही हम 0 लिख सकते हैं.
वहां भी 0 कर सकते हैं, बट ये मुझे थोड़ा अजीब सा लग रहा है. ठीक है, दिस इज ड्यू टू नंबर, बट एक्चुअल थिंग इज दिस वन. ओके, सब्स्टिट्यूशन तो आप अपनी सहूलियत के लिए करते हो ना?
हाँ, सही बात है.
Okay, so obviously 0 to 0 is looked a little bit weird. So actually this thing is there, है ना? So obviously this value is equal to what? 0. So there is not any correction into first excited state. Sorry, in first order correction in nth excited state. Okay. Sin square n ना? This is sin square n. Wait. कुछ गड़बड़ हुआ है ना? Sin square n. Anyway. So this will be n pi. So anyway, every time you have this integration is 0. So don't worry. Clear है ये?
Sir.
हाँ. And cos n and you have n pi. Okay. Just correct it. I am just talking about nth state. Okay.
माइनस आएगा ना cos
क्यों माइनस क्यों आएगा?
डेरिवेटिव दिया है ना सर हमने।
तो साइन का डेरिवेटिव cos तो प्लस आता है, cos का डेरिवेटिव माइनस आता है ना? ओके.
Yes.
चलो, let's go for one more problem and it is more exciting one. So,
सर
हाँ.
तो सर हम लास्ट टाइम जब वो अब जो मिटा दिए उसमें सब साइन n पाई x बाई a को अगर हम t लेंगे
हाँ.
तो उसका डेरिवेटिव निकालने के बाद cos के अंदर भी तो एक n आ जाएगा,
हाँ, cos के अंदर भी n रहेगा. हाँ.
लेकिन फिर उसके बाद हम इंटीग्रेशन में सब्स्टिट्यूट नहीं कर पाएंगे।
Okay. Yes. There is some problem. Okay. क्या है ये? Wait. Good. What is the integration? This will be 0 to a and obviously sine square n pi x upon a and here is cos pi x, na? Okay.
यस सर।
Okay. Good. Something is wrong here. So how we will do this integration? कैसे करेंगे? Good. Very good.
Sir, 1 minus
हाँ.
cos 2n pi x by a.
So what you have said?
Sin square को 1 minus cos 2 theta कर देंगे।
Obviously. So what we will do? Good. 0 to a and we will just go for 1 minus sin square को क्या लिख सकते हैं? Cos
2n pi x
2n pi x by thank you 1 minus cos 2n pi x by a.
और
Oh,
एक बार
and
half
then you have cos pi x by a dx, isn't it? Great.
और एक half होगा सर।
Half होगा, that will become outside half. And यहाँ पर क्या बाहर आ रहा है? V naught. Now we have two integration. One is
2 not by a।
2v नॉट बाय a
2v naught by a. Okay. And 1 half is also there, है ना? So we have v naught by a. One integration is what? Cos pi x by a dx. Very good. It's a very nice problem, isn't it? So मुझे लग रहा है कि बुक में ground state है, मैंने nth state ले लिया है. Very good. So this will be second integration is what? 0 to a and what will be this value?
cos
Cos pi x by a and cos 2n pi x by a dx. Okay, good. So this value is 0, isn't it?
yes, sir।
So this value is 0. And now we have to calculate this particular value. So this is basically v naught by a and we have to go for integration, minus sign is there. And that value is 0 to a cos pi x upon a and cos 2n pi x upon a dx. Very good. Thank you. Sorry, मैंने ध्यान नहीं दिया कि हाँ n था. Okay, now we can open it with cos a into cos b.
yes sir।
Yes. What is formula? मुझे याद नहीं, जरा बताओ formula क्या होता है? Just देख कर बताओ. Cos a into cos b.
सर cos a सर 2 आता है आगे 1/2 सर
1/2
cos a plus b
cos a plus b by 2 भी होना चाहिए नहीं?
नहीं सर by 2 नहीं है
Okay, ठीक है. फिर plus
a minus
cos
a
a minus b. Okay, great. ऐसा ही होगा ना?
yes sir
Okay, good.
यस
चलो, I think answer 0 ही आना चाहिए. V naught by a and cos a into cos b we can write. Cos 1 by 2 is there. Cos pi plus you can write
Pi x plus
2n plus 1 pi x by
X
a,
Yes, sir.
isn't it? And
Yes, sir.
second one is, and we have to go for integration, that is dx 0 to a, and second one is what? Second
Cos
one
pi
is
minus 1
क्या
pi x
होगा
by-
बताओ?
Sir, cos
Plus, and you have integration cos 2n minus 1
pi x by
pi x by a dx. Very good. So what we have? Minus 2v naught by a. Again, it will be 0, I think, isn't it?
Yes, sir. Yes, sir.
And so that will come into sign, that will come into sign. So fortunately, गलत करने पर भी आंसर सही आ रहा था. बट ओके, थैंक यू. किसने बताया था ये?
सर अर्जेंदु.
अर्जेंदु. थैंक यू अर्जेंदु, थैंक यू. ठीक
नो
है,
मेंशन सर.
ओके. चलो, सो ऑब्वियसली, बट यस, वी हैव लर्न कि थोड़ा सा भाई ध्यान रखना चाहिए, एंड हाउ वी कैन गो फॉर दिस. This question will be excellent question if we will go for 0 to a by 2, isn't it?
Yes.
है ना? So why didn't you do this as a homework? Let's do this as a homework. है ना? What is your HP? HP is equal to V naught, and this is cos pi x by a, where x is between 0 to a by 2. So what will happen? This term will come 0 to a by 2, another 0 to a by 2, and it will survive, isn't it? होगा ना?
Yes.
है ना? And then you can easily calculate it. So do it homework, otherwise I will give it in the exam, don't worry. This is a one new question I have found. Okay, great. Let's go for some more problem. ठीक है? Okay. मिटा दें इसे?
Yes,
यस
sir.
सर.
Okay. So let's go for harmonic oscillator, okay? Let's go for in a harmonic oscillator. So first is we have harmonic oscillator. First Vx is given by half m omega square x square. This is your potential energy, and this is your original or unperturbed Hamiltonian, and this is HP is equal to lambda x. HP क्या है? Lambda x. So what we have to do? We have to calculate En1 and psi n1. दोनों कैलकुलेट करते हैं. En1 भी कैलकुलेट करते हैं और psi n1 भी कैलकुलेट करते हैं. So obviously, what is eigenstate for harmonic oscillator?
Sir, n
N-kit. You remember? N-kit, which is basically a functional form of Hermite polynomial and Gaussian. Okay, but we are very comfortable into n. So now what we have to do? We have to just change my x in a operator form. Yes, you remember what is your x? So we have h n is equal to n plus half h cut omega n kit, and what is value of n is equal to 0, 1, 2, 3, and so on. This is our value of n. So now what we have to do? We have to calculate En1. So that value is equal to n x n. What is expectation? What is this thing? That nothing but the expectation value of x.
0.
0.
That is 0, exactly. So there is not any change in a ground state. Sorry, in first order perturbation. So let's go for psi n1. क्या ये भी 0 होगा क्या? Let's try to check. So what is your psi n1? व्हाट इज योर साई n1?
सिग्मा
हाँ, फॉर्मूला बताओ.
सिग्मा
हाँ,
m is not equal to n
वेरी गुड.
pi m
तो यहाँ पर m कैट लिख दे. वेरी गुड. और क्या होगा?
w
w
pi n
n कैट लिख दे. और नीचे क्या
Upon-
होगा?
en0 minus em
वेरी गुड. en0 माइनस
en0
em0.
pi
और यहाँ
m
क्या?
full
m
cat
कैट.
pi m
वेरी गुड. चलो, w की जगह पर क्या लिखे?
x
x. वेरी गुड. सो वी विल राइट m x n. और यहाँ क्या हो जाएगा? en0 माइनस em0. ठीक है ना? एंड दिस इज m. नाउ अब यहां पर क्या करना पड़ेगा? ऑब्वियसली वी हैव टू चेंज x टू व्हाट?
ऑपरेटर
ऑपरेटर मेथड में चले जाएंगे. वेरी गुड. सो x इज इक्वल टू सम x नॉट a प्लस a डायगर. याद है? वेयर x नॉट इज इक्वल टू h कट अपॉन 2m ओमेगा रूट अंडर 2m ओमेगा. इजंट इट? याद है ना?
यस
सो मैं जानबूझ कर x नॉट लिख रहा हूं. इतना बार बार कौन लिखेगा? लास्ट में चेंज कर देंगे. ठीक है? सो ऑब्वियसली वी विल जस्ट गो फॉर m a प्लस a डायगर n by en0 minus em0 summation over m, and we have m is not equal to n, and I will have this particular x naught, and we can take this x naught. Now we will take two things separately. So we have two summation. One is x naught and summation over m is not equal to n, m a n, and this value is en0 minus em0 plus what is this value? m a dagger n, and what is this value? M is not equal to n, and here you have en0 minus em0, and here is m is also clear है ना?
yes
Now
sir.
let's go for a next step. नेक्स्ट स्टेप पर चलते हैं और फिर देखते हैं. So A will operate on n. What you will get?
root n minus
Very good. Root n, and this will be m n minus 1, and here is en0 minus em0 and m kit.
माइनस एम नहीं होगा सर?
हाँ?
नीचे एन माइनस एम. ठीक है सर.
क्या है?
सर वो
इसको मैं-
EM0 माइनस EM0 को बोला था सर मैं. ठीक है सर.
तुम्हें मैं किसी दिन पीटूंगा तेज. ठीक है? समेशन ओवर सेकंड वाला टर्म क्या होगा? A dagger will operate on n.
n plus 1
Very good. So root under what?
n plus 1
n plus 1 m n plus
Plus
1.
1
और नीचे क्या हो जाएगा?
en0 minus
en0 माइनस em0. स्टेप बाय स्टेप करने की आदत डालना है ना? नाउ यहां पर n की कई वैल्यू सरवाइव होगी, कई वैल्यू होगी, m की कई वैल्यू होगी, है ना? तो किसके लिए सरवाइव करेगा? m की किसके लिए, किस वैल्यू के लिए सरवाइव करेगा?
सर n माइनस 1.
n minus 1. So only one term it is going to survive. So that value is equal to n
Sir,
minus. Sorry,
x naught
x naught रहने दो. हाँ, x naught तो रहेगा. Don't worry. Okay. So you have this particular thing. So we have x naught. Now what will happen? Only m is equal to n minus 1 is going to survive here. So we have, और ये दोनों क्या हो जाएगा? n minus 1 के लिए 1 होगा, बाकी के लिए 0 हो जाएगा. So we have root n, and this value is
1.
en0 minus en minus 1 0, isn't it? And this ket is n minus 1. What will be next one?
n plus 1 के लिए.
n plus
Again
1
n is not equal to m, so this value is n+1 और ये m की किस वैल्यू के लिए सर्वाइव करेगा? n+1. So what will happen? This value is equal to en0 minus en+1 0 and that value is n+1. Clear है ये? So what is en minus en1 0? h cut omega, isn't it? So this value is root under n and that is h cut omega n-1 plus root under n+1. And what is this value?
h cut omega.
Minus h cut omega.
minus
This value is what? Minus h cut omega. So n+1. So I can take minus here. So this is negative sign. Okay. So now this is your wave function, first order correction in wave function. So it is not necessary that if there is not any correction in energy eigenvalue, there is not. So you can just make a judgment that okay, there is not any correction in wave function also. It will entirely depends on which type of perturbation is there and how you can approach all this thing. Clear है ना? ठीक है? चलो. So what will be En2? यहाँ निकल जाएगा क्या En2? यहाँ तक कर लिया तो En2 भी निकाल सकते हैं. Yes या no?
Yes, sir.
Yes.
Yes, sir.
So let's try to go for En2. So En2 क्या होगा फॉर्मूला? Summation over m is not equal to n phi m w phi n इसका mod square by en0 minus em0 है ना? So we can take equal to, इसमें क्या हो जाएगा? This term will basically कौन कौन सा टर्म सर्वाइव करेगा फिर से जरा बताओ.
से दोनों सर n-1 n+1.
So basically we have summation over m is not equal to n. So we have m a n and इसका क्या होगा? mod square, isn't it? और नीचे क्या आ जाएगा? en0 minus em0. Second term is, and here is x0 square, है ना? This is x0 square. And this value is equal to summation over m is not equal to n. And what you will have? M
a
a dagger n and you will take mod square and you have en0 minus em0. Now अब ये तो हमने कभी तुरंत कैलकुलेट किया था. What will be this term? ये term कौन सा होगा? So only root n will be there, isn't it? So only one term will survive. वो क्या हो जाएगा? Root n mod square and this is en0 minus en-1 0 plus root n+1 mod square by en0 minus en+1 0 और साथ में क्या हो जाएगा? You have x0 square. Clear है ना?
yes sir
So what is your n square?
n
N by this is what? H cut omega. And this will be plus n+1 minus h cut omega. Yes. And what is your x0 square?
h cut upon 2m
Very good. H cut upon 2m omega. So now क्या हो जाएगा? H cut cancel 1 upon 2m omega. Minus sign आ जाएगा ना? So this will be, I think, En2 is equal to minus, and then what will be there? 1 upon 2m omega square. सही लिखा हूं? You can just check. और आप अगर याद हो आपको एक प्रॉब्लम जो मैंने हार्मोनिक ऑसिलेटर में बताया था, जिसमें मैंने हार्मोनिक ऑसिलेटर के जगह पर के साथ साथ एक और पोटेंशियल लिया था माइनस लैम्डा एक्स, रिमेंबर?
Yes, sir.
लिया था, याद है? कुछ ऐसा था, H इज इक्वल टू पी एक्स स्क्वायर बाई 2m। आप देखो कॉपी में पलट कर देखो, m ओमेगा स्क्वायर एक्स स्क्वायर माइनस लैम्डा एक्स या प्लस लैम्डा एक्स, कुछ ऐसा लिया था, याद है?
यस सर।
और उसका जो कंप्लीट सॉल्यूशन हमने लिया था, वो कंप्लीट सॉल्यूशन क्या आया था? n प्लस हाफ एच कट ओमेगा माइनस लैम्डा स्क्वायर बाई 2m ओमेगा स्क्वायर, याद है? आया था?
सर
यस सर।
Just check it, just check it. You can check in your harmonic oscillator chapter. आया था ना? So this kind of thing will be there. Yes?
Yes, sir.
And you can see second order perturbation पर हम जा रहे हैं, then we will get the complete solution, exact solution, isn't it? First order correction में exact solution नहीं आ रहा था. किस solution तक exact solution आ रहा है? From the second order approximation पर आप जा रहे हो, then you are getting what? Exact solution. ठीक है? Okay. So let's go for one more problem. चलो, HP is equal to lambda x square and potential is again your harmonic oscillator, half m omega square x square. Okay, so you have to calculate En1 and then you have to calculate psi n1 or En क्या calculate करोगे? Let's calculate psi n1. Okay, En2 will be your homework. Okay,
Yes, sir.
is your homework. ठीक है? Let's try to go for this. What will be En1? En1 is n cat W n cat. So n cat x square n cat. इसे क्या लिखेंगे? A square A dagger square plus 2n plus 1. याद है?
Yes.
Okay, this is your x naught square. Clear है ना?
यस सर।
So this will be, which one survive? A square will not survive. A dagger square is also not survive. Only 2n plus 1 will survive. So this will be x naught square and that value is integral into 2n plus 1. Clear है ये? है ना?
Yes.
Okay. Let's go for psi n1. Psi n1. Again we will go for summation. Now m is not equal to n. So you have m x square n and we have en0 minus em0 and there is m cat. So obviously the first term is going to m is not equal to n. So x square is this one. So this is, so let me write first thing. So this will be m a square n and you have en0 minus em0 m cat. So how many sum is there? 3 sum, na?
Yes. Sir.
M is not equal to n. M a dagger square n and we have en0 minus em0 and this value is again m and plus this term is also there. So this term is m is not equal to n. M 2n plus 1 n and we have en0 minus em0 m cat. यही तीनों को तो निकालना है, ठीक है?
Yes. Sir.
So let's go for a next level of calculation. So what we are going to do? So okay, so a square will go up to this. What you will have? Summation over m is not equal to n. You will have root under n minus 1, isn't it?
Yes, sir.
And when you have m and n minus 2, and here you have en0 minus em0, and this kit is what? M kit plus. What about second term? What about second term?
root n plus 1 into root n plus
Just
2.
a minute. So second one we have m is not equal to n. रुक जाओ यार, इसको थोड़ा इसको ड्राई हो जाने दो. चलो. So m is not equal to n. What we have? Root n plus 1, root n plus 2, m and n plus 2, isn't it? And you have en0 minus em0 and m kit, and third term is also there. What you will get? M is not equal to n. What is this value? 2n plus 1.
Yes,
है ना? 2n plus 1. And you have m and n as well as en0 minus em0 and m kit. My goodness, it's a wonderful problem, isn't it?
सर थर्ड टर्म तो 0 होगा.
थर्ड टर्म 0 होगा तो अभी करेंगे ना, अभी तो कुछ भी 0 नहीं किया है. ठीक है. Which term is going to survive for m here? कौन सा term survive करेगा? n minus 2. All other term will be 0. So here is en0 minus en minus 2 0 and n minus 2. Great. Second term, which term is going to survive? N plus 2. You have n plus 1 root n plus 2, and you have here en0 minus en plus 2 0, and you have n plus 2 plus. What about this term?
0.
That term is 0 because m is not equal to n, and this is Dirac delta mn. So this value is 0. And now what is this value?
2h का term.
2h cut omega. Great. So this value is root n, and obviously x square is there. So don't forget this dimension. So this value, and you have 2h cut omega. I can take negative sign here, isn't it?
Yes.
And that is, and obviously n minus 2, and you have to go for root under n plus 1, root under n plus 2, and this is negative sign 2h cut omega, and this kit is n plus 2. Yes, and you have x naught square.
n minus 1 होगा ना सर? n minus 1 फर्स्ट टर्म.
किसका? हाँ, n minus 1 obviously, या तो ऊपर लिखा ही हुआ है. ठीक है. So obviously these are our solution. So you can just go and calculate en2. कर सकते ना?
Yes sir.
Yes, sir.
So just try to do en2. Okay. So this is one set of problem. Go and try to do all the problem in your tutorial. All problem are very nice problem. Okay. जैसे आपने किया होगा वेरिएशनल और W के भी का, तो आपको समझ में आ गया होगा, है ना?
Yes, sir.
जिन्होंने नहीं किया